Before getting a deeper dive into what exactly is React Fiber, take a time back and jump into the older topics, one of which is abstraction out of OOPs. And abstraction is clearly visible at the entry point of a React application, which is this very app.tsx or app.js, which is clearly visible to any of the React application. Rather, you create it with the help of CRA or White or Weed, however you want to pronounce that one. So yep, so I was on this particular screen. This is like one of the component which shows the example for both of the algorithms. The previous one, the React uh, React Fiber, which is on the right hand side, and the left hand side is shown with the help of recursive algorithm, which is responsible for your the DOM manipulation. So the previous one is having certain of the hinges, and those hinges are clearly visible because of the frame drops. And frame drops, when I say frame drops, basically I mean to say that there are certain procedures that is entirely different story. So there are certain procedure how this HTML CSS things are coming up on your DOM, and how this pixels, this LCD, LED, whatever screen you are having, that is getting painted. So that is actually responsible for giving you a fluent, that's the better word to say, a seamless, I think that's the better word to say, a seamless view of any of the application, any animation or anything. Now, these hinges which are getting caused because of this stack algorithm, that will cause certain of the hinges, certain of the delays will be there. Now, React Fiber get us introduced with certain of the asynchronous operations. Now, these asynchronous operations are there. So, okay, so when it is asynchronous operation, I need to draw your attention towards one thing which we would have, must have gone through, which is named as global execution context. Because when it comes to the global execution context, probably that explains the best how actually JavaScript explain the asynchronous operation of itself. So I just want to let you derive your analogy out of global execution context, and hold it in your one left hand or right hand, any of your favorite hand, and just hold on to that global execution context analogy. And I just want to draw your attention towards the refinement of what exactly I have told you about the React Fiber. So I believe everyone would have come across this statement in JavaScript, that everything in JavaScript is nothing but an object. So tada, even the React Fiber is. React Fiber is even the simple JavaScript object which is holding certain properties of the React element. Now the new jargon is into the town, which is React element. So there are two of the statements which can be a little bit of confusing. One is React element, one is React component. So React element is nothing but the clearly the JSX, which you can use without supporting of any of the UI libraries. And when those JSX are getting combined, you can clearly observe the combination of those JSX in the form of React component. Now, these are few of the properties which are visible to us, which can be the property of the React JSX React element. Now, so coming back to this thing which we had held in our favorite hand, the global execution context. So how, let's just revise what was happening inside this global execution context. So let's suppose there is certain operation which is going on, and then that operation is having certain asynchronous operation that will go into the web API. It will then wait over there, it will go into the respective queue. Now event loop will find, okay, now my main thread is empty, I would have to push it into the main stack. So now that's how the asynchronous operation is getting handled. So is there any event loop inside the React Fiber too? So not exactly event loop, but there is something similar to event loop, which is named as requested idle callback. So that is again an implementation. If your browser supports that one, well and good. If your browser doesn't support that one, even better, because React team has taken care of that thing with the help of their polyfills. Now that polyfill will help you out to replicate exact operation of this event loop. Now, let's take an example. That example will be showing you how exactly this DOM manipulation thing is going on. So this DOM manipulation thing, I'll take an example. Let's suppose there's one list component is there that is having this list, which is having UL element, and there will be LI element showing this 1, 2, 3 digits, nothing too much fancy about it. There is one button, you will click on that one, that will make the square, and the square of each of the individual numbers. So now, just making a wild guess, let's suppose you clicked on that button, it is squared, and in order to make things little bit more complicated, let's just introduce one more button, which will be responsible for increasing the size, the font size from X size to 2X size. Now, in the chat box, you can make your wild guess how this updation would happen. Will it be like, okay, first the squares would happen, 1 will get squared to 1, 2 will square get to 4, 3 to 9, and then the size will get increased. Is it so or is it not? Answer I'll give. You can make your wild guess inside the this chat area. So let me tell you that there is, with the help of requested idle callback or this polyfill, there will be actually two phases which will be responsible for this DOM manipulation. One is the render phase and one is the commit phase. So render phase always has the higher priority. That's the point number one, which we have to take in grasp from this thing, from this discussion, from this slide specifically. So render phase is having the higher priority. So render phase is responsible for the logical manipulation, and the commit phase is responsible for the cosmetic changes. Now, answer to that question which I had asked about, that how exactly this manipulation would happen. So answer is, first 3 will get changed. 3 will get changed to 9. 9 will get increased its size to 2 times, and then 2 will get changed to its size of, sorry, 2 will get changed to 4, and then its size will increase, and so on and so forth. The 1 will not get updated, 1 only size will get updated. So that's how this updation is happening. So in order to give the graphical representation how this thing is happening, okay, I can draw your attention towards this thing. Let's suppose there is one component, this root. Obviously, I believe everyone is familiar with this index.html, where there's div, there's root with an ID. There's a div with root ID, and then there comes the list component, and there's a button, as what I had just created the analogy for. So there are list items li1, li2, li3. How this updation is happening, that you clicked on the button, some state updation process is getting flowed. It's like a waterfall is falling, again, from one step to another step to the third step, and the feedback is given back to the list ultimately. Now, but the updation is in asynchronous operation. If you remember this diagram, this one, yeah. So there is a continuous feedback. There is a continuous feedback. 3 has been updated to 9. 2 has been updated to 4. Maybe time span has got completed. I have to increase the size of 3. Okay, then the redo work will happen. I'll come to this redo part, what I have just said. But I guess this diagram makes sense. So, okay, moving ahead. So now there are two replicas are there. One is the current tree, another one is the work in progress tree. So there are two trees. Okay, why I'm even talking about the trees over here? So trees, because I believe in any of the React component, you cannot export two of the JSX elements simultaneously. One is the major reason behind that one is because of the tree structure. Okay. Now there will be two trees. One will be the current tree. Another one will be the work in progress tree. The current tree is responsible for what you are actually seeing on your DOM right now. Work in progress tree is something when your current tree is getting updated in. And so it's like a copy which you are creating. Okay. And yeah, one thing, just to hold on. In React 16 or even before, I believe there was this concept which was introduced, which is named as error boundaries. Now, the error boundaries into the picture only because of this work in progress tree. Because previously, how it was like, okay, something had happened in your something had happened. Let's suppose something went wrong, maybe at this item two. So there should be some fallback where you can land upon. How would you get that? You will get that with the help of these two replicas of the trees. One is the current tree, another is the work in progress tree. Cool. Now, there is too many of the copies are there are too many of the asynchronous operations are there. So I would just take a step back and think about if you would have ever thought about how this microservices used to work. So when it comes to the microservices, there's also there, because there are always too many services are running, and again, we would have to maintain the consistency. Such a thing inside an operating system, such a thing was first introduced inside the operating system, and this terminology, which is named as cooperative scheduling. Name is little bit fancy, but yeah, I guess it is self-explanatory. Anyway, so there are two major concepts. So there are two major drawbacks which comes along with this asynchronous slash dividing of your work into multiple tasks. So one major problem is consistency, because now you have divided your task. How would you maintain the consistency? That's a problem. And the second problem is, okay, you have one thread, you have reduced that load of manipulating the entire of the DOM at once. Then probably, then while having this division, there will be certain starvation situation also, because your main thread will be probably a higher priority task is taking more time, then your lower priority task will be forever be starving. Who knows? So is there any solution to that one? So answer is yes, there is a solution to that one. Especially, I would first draw your attention towards this consistency thing. So React team, what they did, they went little bit more smart. So how did they this? How did they actually introduce this consistency thing? They have introduced the multiple workers at each of the elements. Now, each of the this React or web workers, they will be responsible for a continuous feedback. Okay, something is going on, some updation has happened. I should be responsible for showing these changes on the DOM. Now that consistency problem is clear. Now, one thing which need to be noticed over here, that this starvation thing is coming into the picture only because of this priority thing. Still, that's an unsolved mystery, and I guess React team will be working upon it, and probably they would have solved it. But this prioritization thing has also introduced us to one more topic, which is really, really responsible for optimizing our React application. And you can make your wild guesses, but I would just let you know about something called as lazy loading. Think about it. Is it not lazy loading the clear outcome of this operation where the prioritization thing is coming up? So yes, React Fiber is again responsible for error boundaries. React Fiber is again responsible for an optimized rendering. React Fiber is again responsible for lazy loading. How amazing. One thing can solve many of the problems. But okay, let's just jump back to one of the clear war which is probably every development team has to suffer, which is whether you should be concerned about data structures or not. So I guess data structures and algorithms are getting used inside our development. It's just they are really into the deep, so we have to be concerned about them too. So again, drawing your attention towards how the previous algorithm was created. So previous algorithm was on recursion. When it comes to the recursion, auxiliary stacks will come into the picture. Auxiliary stacks are coming into the picture. So your operation of first in, last out operation is going on. That is again making us recall the school time concepts of stacks. And if you talk about how this React fiber is getting formed, what exactly the data structure is getting used inside that one is. So there are two data structures which are getting used inside that one. I'm taking the example of that, the same example. So these components, these React components, that's the reason why I draw your attention towards these two elements. Sorry, these two terminologies. One is React element and another is React component. So React component are forming the tree-like structures, and React elements, which are nothing but the siblings, they will be forming the structure with the help of single linked list. They will be interrelated with the help of single linked list. So they are these two data structure, tree data structure and single linked list, they are replacing the previous one, which is the stack implementation. And again, this article, this representation, and the knowledge whatever I have gathered, that won't be possible without these of the few of the developers who are doing an outstanding work, especially to the meta developers. If you are not following to the React meta developers repository, I would highly recommend, please do follow that one. That will just blow your knowledge about React to the next level.